This is Year 10, homework 17 for Mr. Reed's Maths group. Due on Friday, remember to meet that deadline. If we look at question 1, it's a repeat of last week's. We're still sharing in a ratio, some of you struggling a little bit, particularly with the problem solving aspect of ratio. So we've got a simple share an amount in a three-way ratio there. Question B is about where you don't know the total. So you've been told you're sharing some money and the ratio information, and you've got to work out how much each person gets, given this clue here. And then we've got hats and coats in this final question. Remember last week we had cats and dogs? So if you look back at your purple pen work from last week and your answers in last week's homework, it should help you. It's exactly the same type of question but with different numbers. If you've got some hats and coats in this ratio, and it happens to be that there are 36 hats, how many hats would you need to add into that situation to make it so that there is a 1-to-1 ratio of hats and coats? If we look at question 2. Now this is a topic that we will be covering this week in class, so if you are starting this homework on Sunday, you'll have to think back to what you did in Year 9 on this topic, but as I've said, we will be looking at this in class, so possibly leave this for now if you're stuck. You've got to work out the upper and lower bounds of each of these amounts. So I'll just give you a clue here, assuming that this 50 has already been rounded. So that's the answer after a rounding calculation has happened. How big was it, or how small was it before that rounding occurred? And this clue over here is essential. It tells you how the rounding happened, and that is a big clue as to how big or small it was before. Same on all the questions there. And questions F, G and H really highlight that it isn't this number here that is the problem, it's this information on this side that tells you how to find the upper and lower bounds of a number. So you'll see these are all the same, and that's deliberate. Question 3. Solving simultaneously. There's two things to do here. I've shown you this in class. We need to practice both. First of all, algebraically, I'd like you to solve these using some algebraic method. Question 4. Solve the same equations but this time by drawing a graph. And a big clue, you should remember this from previous weeks in my classroom. You need to draw both of these graphs on the same axes and then look for the point of intersection, and that's how you solve these graphically. Question 5, if we move on. There's 4 different transformations shown here. We've got A, B, C and D, and in each case A turns into the image A dash, A turns into the image A dash, and so on. And you've got to fully describe the transformation in each case. So there'll be a sentence for this one, a sentence for this one, and again here and here. And some clues. The point P needs to be mentioned when you are talking about this transformation. This point Q is relevant here, something to do with this transformation. And this one's drawn on axes for a reason. There's some sort of line that's relevant when describing this transformation. The last clue I'll give here is you can't get full marks on this topic if you don't properly describe which transformation it is. So I'm talking about enlargements, reflections, rotations and translations. So please make sure you do use the appropriate word when describing each of those. Let's move along to the next question. This is the last page, and it looks like an exact copy of last week's homework, but it isn't. The numbers are different, and in fact the difficulty has been ramped up a little bit. That's awkward. There's minus signs everywhere. These fractions are awkward. So actually it's just a push on from what we did last week to try and step up the difficulty in case the test has got questions at this level. So give it your best, and I don't want an equation of a perpendicular line. If you read the question, I just want the gradient of any perpendicular line. So you need to look at the gradient here and think about that rule to do with reciprocals. That's it. It's the end of the homework. If you get stuck, please come and see me at break time before that Friday deadline.